Hey everyone, and welcome to This Explainer. Today we're putting you directly in the driver's seat as a senior multi-cloud architect. Your mission? Well, it's to conceptually design absolutely flawless, robust, hybrid connectivity between your on-premises environment and AWS. So whether you're entirely new to cloud networking or you're just looking to, refine your existing infrastructure, we're going to break down this incredibly complex web of connections into a clear, actionable architecture. Let's get right into it. So let's dive into this core headache that pretty much every growing enterprise faces at some point. How on earth do you connect one data center to dozens of VPCs without creating just an absolute management nightmare? Because it really is a massive challenge. When you've got just one cloud environment, sure, things are pretty easy. But as your business scales up, your network complexity can literally skyrocket. And that leads to routing errors, security gaps, and total operational chaos. Okay, here's our architectural blueprint for today. We'll start with designing hybrid connectivity, then weigh VPN versus Direct Connect. After that, we're mastering the transit gateway, looking at routing, security, and availability. And finally, we'll wrap up with the network team checklist. All right, Section 1, Designing Hybrid Connectivity. Let's build that baseline. Now, as an architect, your primary job is to conceptually design a network that makes AWS feel like a seamless, secure extension of your own physical building. Seriously, when an employee in your physical office pulls up an internal app, or say your on-premise database syncs up with a cloud analytics tool, they shouldn't know or frankly even care that the data just traveled hundreds of miles. That seamlessness, where the physical and the virtual just blend perfectly together without any friction or lag, man, that is the absolute holy grail of hybrid cloud design. Moving right along to Section 2, VPN versus Direct Connect. This is all about choosing your path. Okay, I absolutely love this comparison. Think of a site-to-site VPN as a highly secure, armored car driving on a public highway. It's encrypted, it's safe, but it's still out there sharing the road with everyone else, right? It's subject to the traffic, bad weather, and just the general unpredictability of the open internet. On the flip side, Direct Connect is literally like building your own private toll road directly from your data center straight into AWS. It's entirely yours, it's incredibly fast, and there is absolutely zero public traffic to get in your way. So balancing your immediate need for speed against your long-term requirements for performance and privacy is super crucial here. A VPN, it's incredibly cost-effective and really fast to spin up, which makes it a fantastic deployment choice when you're in a pinch. But you are completely at the mercy of internet stability. Direct Connect, meanwhile, gives you that dedicated bandwidth and beautifully low latency. But there's a catch. It requires physical telecom provisioning. That actually means technicians laying down real physical cables, and that takes time, planning, and obviously a much larger budget. You really have to weigh these trade-offs carefully based on your exact workload demands. All right, Section 3, Mastering the Transit Gateway. Let's talk about scaling the enterprise. You see, when your enterprise scales beyond just one single VPC, that initial single connection just isn't going to cut it anymore. You need a transit gateway. This is basically a central cloud routing hub that connects your virtual private clouds and your on-premises networks all together. Think of it this way. Instead of building individual point-to-point roads between every single neighborhood in a massive, sprawling city, the transit gateway acts as your giant central highway interchange. All traffic flows through this one central point, which makes routing exponentially easier to manage and govern. Now, if every single VPC needs to talk directly to your data center and every other VPC, you very quickly end up with this tangled, chaotic web of connections. In the industry, we jokingly call this spaghetti architecture, and let me tell you, it is a total nightmare to troubleshoot and nearly impossible to scale. But by dropping a transit gateway right in the middle, you create a hub-and-spoke topology. This instantly centralizes your network, radically simplifies your management overhead, and, most importantly, it makes the whole shebang highly scalable. Need to expand? You just attach a new VPC to the hub, update a few route tables, and boom, you're done. Let's actually trace your data's journey in this hub-and-spoke scenario, just to make it concrete. First, your data securely leaves your on-prem data center. Then, it travels rapidly down your private Direct Connect toll road and arrives right at the central transit gateway hub inside AWS. From there, the transit gateway inspects the address and intelligently routes it directly to its final target VPC. It's just such an elegant, logical, and highly efficient flow of data that completely removes the guesswork from cross-cloud communication. Moving to Section 4, Routing, Security, and Availability. It's time to secure the perimeter. As an architect, there are really three core non-functional requirements that'll keep you up at night: availability, security, and routing. First up, high availability. The big challenge here is a physical connection failure, right? So our architectural solution absolutely has to be redundant links. Second, security. There is a persistent threat of data interception over the wire, which means leveraging IPsec and robust encryption is simply non-negotiable. And third, routing. Managing complex traffic flows at scale means we need dynamic routing protocols that can automatically adjust paths as the network inevitably shifts and changes over time. Listen, a single point of failure is an architect's absolute worst enemy. You must always build for failure. Let's say your one direct connect line gets accidentally severed by an errant backhoe digging up the street. Hey, it happens. If that occurs, your entire hybrid cloud setup goes completely dark. And this is exactly why we mandate redundant connections for true high availability. You might pair a primary direct connect with a backup site-to-site VPN, or maybe utilize two separate direct connects in completely different geographical locations. Redundancy is not a luxury, folks. It is the absolute bedrock of enterprise reliability. Finally, Section 5, the Network Team Checklist. Let's turn this into an actionable design. So as a senior multi-cloud architect, here is your mandatory pre-flight checklist. You've got to run through these with your network engineers before deploying anything. Number 1, what are our exact bandwidth requirements? Seriously, don't guess, analyze your traffic, and actually calculate it. Number 2, do we have redundant physical paths to guarantee high availability? Number 3, what are our strict encryption standards to ensure our data is never compromised in transit? And finally, number 4, which dynamic routing protocols, like BGP, are we going to use to ensure our transit gateway can adapt to network changes automatically? Having clear answers to these specific questions is what separates a pretty good design from a truly phenomenal one. All right, I'm going to leave you with this final, hopefully thought-provoking question. Look closely at the systems you've built, or the ones you're planning to build right now. Are they merely surviving today's traffic, or are they truly architected with transit gateways, solid redundancy, and scalable routing to handle tomorrow's unseen workloads? Taking the time to architect this hybrid bridge correctly today will save you countless headaches down the road. Thank you so much for joining me to explore the wild world of cloud connectivity in this explainer. Keep questioning your designs, keep building resilient systems, and I'll catch you next time.